Hi. Today I'm going to talk to you a little bit about dependency injection and inversion of control. This is going to be really simple. Hopefully with this little PowerPoint and a tiny demonstration, I can give you some basis of a beginning to understand kind of the patterns we're using in the InvVM tutorials that will follow later. So this is just about dependency injection and inversion control, specifically using Microsoft's Unity container. So these are some slides I pulled off the internet. Half of them I don't know what they mean. I deleted some of them, but I think it gives you a basic idea, and then we'll do some code. So what's a dependency? I think everybody knows. Common dependencies include application layers, maybe your data access layer or business layer. Maybe you have external components that your class needs. Those are dependencies. Here's a kind of a high-level look down. So you have a user interface which depends on the business layer, which is your computational layer that does all the work. And that maybe depends on a database layer, or maybe depends on your file I/O if we're working with files. This is kind of a database flow here. But you can see kind of the flow from top to bottom. This object depends on that, which depends on this. And this is kind of simple. We've all seen with projects, those dependencies start out really flat, and then pretty darn quickly you get a daisy chain of dependencies. And how you handle those dependencies can make your code really yicky if you don't have something in place. I don't like this slide. What problems do dependencies create? So why do we not like dependencies? Well, when you have a lot of dependencies all over your code, you can't even construct class A unless you construct 20 other classes, which can construct 10 out of those classes. It can get really out of hand quickly. And when you start trying to unit test that, oh man, it is impossible to mock up all the objects necessary for you to test one method inside of one class. So that's the second point. It's difficult to isolate when testing, difficult to maintain. You don't even know what you're dealing with when you've got a class that has so many hidden dependencies. They're all throughout it. You don't even know what you need to actually make that class work. So dependency injection is the ability to supply or inject an external dependency into a class at runtime. And what we'll show you is there's three different types of injection you can do: constructor injection, setter injection, or method. I'm only going to show you constructor. The other two exist and you can use them, but everywhere where I've done dependency injection, it's generally thought of the other two methods are not good. Constructor injection is the best because you can see right at the constructor what's the contract needed for this class to do its job. If you have setter or method dependencies, then that means you have injection happening down in the class where you can't see it, and it's much harder for someone to come back and unit test it to know what I got to give this class to make it work. So constructor is all I'm going to show you. Here's an example of a class that has two dependencies, a custom repository and a custom DTO mapper. And then here is showing kind of the syntax you would use when I want to inject dependencies for this. So I have the interface for repository and interface for the DTO mapper passed into the constructor of the customer service object. And then in the constructor we can assign those to our fields and we can use them throughout our whole class. So this is a good example of that constructor-based injection. Now you could just run this without any inversion of control engine. That's compilable code. And when I construct a customer class object, if I just make sure I grab my repository guy and my DTO mapper guy and feed it to the constructor of this customer server, it'll work. But I'm going to show you how you take this method and hook it with an inversion control engine like Unity, and all of a sudden you can construct classes all over the place and you don't have to worry about where you're going to store the repository object or the mapper object. This is going to be really cool in a minute. So here are the pros and cons of dependency injection. The pros are everything's loosely coupled, which is really cool. It increases testability a lot. It really does. It's really easy to test stuff when they're done through dependency injection. It separates your components really cleanly, allows for use of inversion control container, which I'm going to show you. The cons are it can be a little complicated. It can be a little magic. Sometimes people look at dependency injection and they go, well, you're constructing it, and here's all these arguments to the constructor. Where are you getting those? That seems kind of magic to me. It is a little magic, but if you understand what's going on underneath, it's as magic as you saying new up a new class and wondering, well, where did it new it up from? Where did you get that memory? If you're able to let go of that kind of ambiguity, you can let go of this one once you see this. All right, so let's do some code. So here I have a basic class. Here is a simple ILC class. In it, I just have, if I just run this, it's console app, it's got two classes in it. Class A, which has a message string, so this is an auto property message, and then a class B just has a number. Now, if I'm going to do, I can construct these classes pretty easily by saying class A equals new class A. Done. Class B equals new class B. Okay, that's as simple as it gets. Everyone understands that. That's not a problem. So let's pull in some of these other classes. Here's a class C I've got. Yeah, I kind of wrote these beforehand, but so they have a little bit more code than they need. Let me see if I can clear it out. Here's class B, or class C, which has a dependency on a class A and a class B object being passed into its constructor. If I go over to my main, I can say class C equals new class C. Now I can't construct this without giving it class A and B. Now I can use the ones that are above, so I can say A and B, or I could do a C1. I could say here I want a new instance of A and a new instance of B, and that works. And if we were to run this, probably don't need to. You guys are smart enough to know that this will create a class C. It has both of those. This created a class C1, and those are all hooked up too. So there is dependencies with classes without any inversion control. So what I'm going to now introduce is the Unity container. So right here I type Unity container, and I'll call it IOC for inversion control equals new Unity container. There. I have now the Microsoft Unity container installed. Now I can use the Unity container right off the bat without any other work. I can just now get rid of this new and use the Unity container to construct new classes. So I say IOC dot resolve, and I actually just want to resolve a class C. That is completely valid. What that's saying is, I want you to go create me a class C, and whatever concrete implementations are required to create a class C, create them and give it back to me. So when we step through this code, we make our Unity container, we create our class A, create our class B. Now here, class C, I step over it, and I've got a valid class C. It generated all we needed in class A and B. Now to make this a little more interesting, we want to see what's actually in these. So let's go to class C, and let's create fields out of these. We do. A field for A, this is just using ReSharper. You could just type this out. So all it does is saying when A comes in, assign it to my member variable M of A, MA, and MB. Okay? And then what I want to do on these, well, I think these are okay. Okay. So now if I go back to program C, we can step through this again. And now you can see in C, I've actually got an A with a message null and a B whose number is 0. And you think, well, that's pretty slick. That is slick. But what happens if I have something in A? So let's say its message equals this is a test. So if we step through this, it'll create an A, and the A has message this is a test, and B, the default constructor for B will set the number to 0. Then we resolve a class, and what do we have in C? We have a new A and a new B. So it constructed it didn't use these implementations at all. It constructed new implementations when it built them. But what happens if I have a dependency that I actually want shared amongst multiple objects? Well, this is where you can start doing some cool Unity stuff. So I can say IOC.register an instance, and I can just pass it A. If I register instance A, it knows that A is of type class A. So whenever class A is asked for, it'll give it the instance that we already have. So let's step through this and see if this does what I think it'll do. So create our class A, register our instance, give me class C. If I look in class C now, notice I got the singleton instance of class A message this is a test. So every single time I now ask to resolve a class C, it's going to use the one I created right there. That's cool. So now I can have a common object. Let's say I'm working with a file IO object or a web object or whatever. You guys have all seen millions of reasons you want to use a singleton. This is a construct once, allocate everywhere you need it, and it's always going to get a copy of that same object, which is super cool. All right, so where the Unity container really gets cool is when you start using interfaces. And I've created interfaces here for A and B. Here's the interface for A, which is basically just like a pure virtual function. If I go to A now, I say, well, this now derives from the interface I class A, which I should actually include into the project. Okay, so that's included. In class B, I want to also include I class B. And then for class C now, instead of using hard implementations of class A and B, which is harder to test, because if you're going to create a unit test for this, you really want to be able to mock the class A and class B objects. Because you may have a class A object. Maybe that class A is a file IO object, which can go to the hard drive and pull stuff. And the class B is a database object, and I go walk through the database. When you're doing unit tests, you don't actually want to troll the file system, and you don't actually want to troll through the database. You want to be able to mock those. To mock those, it's really hard to do with an actual hard implementation of a class. You want to use the interfaces. So let's change this to an I class A, an I class B, and this with I, which means use the interface of. Okay, and now here, if I were trying to run this now, I'm going to get an error. So I step over my Unity container, I register A. Now it's going to try to resolve class C, but it requires in that class C two new definitions, an I class A and an I class B. And when I step over this, Unity is going to blow up and say, hey, I can't figure out what is your class that is the definition for an I class A. And it would have said I class B too. So how do we get around that? We just need to teach Unity how to resolve those. So I say IOC.register a type, and here I give it the type of an I class A, and I say this is the interface type, and this is the actual hard class implementation of that. So I say class A. And let's do it also for B. Okay, so now I've registered two different types, class A and B, and let's see what happens.